Hello, hello. Thanks for coming, everyone. Please take a seat. So good evening, everyone. My name is Joe. So I'm from H2O. So thanks for coming to this meetup. So I know there's a confusion between the RSVP and the invite. So it's hard to gauge how many of you actually come up. So please allow me to use two systems for the registration. So tonight I want to give you two talks. So from my colleagues, Mario is there, and then from the author of H2O book, Darren, behind me here. Okay. So before that, I want to give you a quick introduction of this meetup, just a quick one. So you see, these are the meetups around the world. So we're trying to create more community expansions around the world. So we have here in London. So next week, I'm going to Dublin for another meetup on Tuesday. So if you remember, if you came to my first meetup, you know that this is my job. So I got there, I took a photo, and then I threw out. But unfortunately, my boss could be here, and then my colleagues are here, so I need to be more serious today. But nevertheless, let me take a picture before I move on. So all you need to do is smile, okay? This is not a device from MIB, so it won't erase your memory. Okay, so you want to come here, please, Peter?
Go around the side.
Yeah, I go around here. So, when you're ready, okay, job done. So another thing I want to say is that we only seriously have this meetup back in February. And the first meetup you can see is back in late April. And now we have nearly 3,000 members. So thanks for your support and interest. So it's not only about H2O here. We want to talk about any topics regarding AI, deep learning, and machine learning. So if you have anything interesting or any interesting topic that you want to present, just give me a shout. Or you can email me, so joe@h2o.ai. So I want to thank my friends as well, because before Mario joined H2O, so I was the only H2O guy in UK. So I couldn't do much about meeting or networking without my friends. So London R Meetup, the Cargo Meetup, where I met lots of friends here. Data science for IoT from Ajit. He's also in the audience somewhere there, Ajit. And then the Women in Cargo Meetup, and the Our Ladies in Global. So I want to thank them for helping me to give me more chances to do the networking and to do meetup with their events. And most importantly, today I want to thank Peter Tam here from Swap Direct. So he's giving us this wonderful, beautiful space for this event. So I want to let him say a few words about Swap Direct.
That's what I was going to say about it. Yeah, welcome everyone. Some of you might know me over the years, some of you don't. I'm one of the talent partners here. I only joined 5 months ago, and this area has been open for about 5 weeks. So they've done a fantastic job. It's so vacant, we are hiring, so if anyone wants to speak to me at the end, you can. Stephen is around here somewhere also, who's down from Liverpool. But ultimately, I've known Joe for about 3 years, there is, and we got talking a couple of weeks ago, and now we have another meetup here. I'm hoping we can do this more regularly, because I love hosting them, I love coming to them. And just a couple of housekeeping things. The toilets is basically on the right side, both male and female if you want. Switch off your phones, because they're going to do talks. No one likes a phone ringing. Apart from that, enjoy, and if anyone wants to speak to me throughout the day or the night, go ahead. Anyway, I think that's all. Cheers.
Okay, so let's start. So first talk is about Darren. So Darren, he is the author of the H2O book, if you have one. Have you bought the book? How many of you have got the book, H2O book? If not, there's a humble bundle now, so you can only spend $8 or more, and you will get the book. So I'll send you the link later on the Meetup page. Okay, so Darren, are you ready?
Yes.
Okay, let's switch over. The floor is yours.
I should have the microphone. Can you hear me at the back?
Yeah.
And we're using a rather complicated way to connect to the monitors. So let's see if this works.
Am I showing?
Yes.
There we go.
Okay. And we're still working. Great. So thanks to all of you for turning up. It's a good turnout. I'll be giving a book away at the end of the meeting to encourage you to stay to the end, and I'll be asking a question, so you need to pay attention. Right. So the plan is I'm going to introduce myself, and that will merge into an introduction to H2O. Then I'm going to do a live demo with deep learning. And then at the end, I'm going to do an advanced topic, which will, for some of you, will wake you up and get you excited, and for others, will have you clutching your head with pain. Oh, yeah, so as my business card shows, my name is Darren Cook. I work for QQ Trend. We're a data company, everything to do with data, right from the mundane stuff, merging, screen scraping, joining, finding data sources, right through to the fun stuff. Data visualization, including VR, NLP, natural language processing, including a lot of, as you can see, Asian languages, and also machine learning, of course, as well as deep learning. Can I get through the wall? Yes. This was a demo I made for a talk about 18 months ago on the subject of using WebGL for data visualization. And I kind of hacked into it for an H2O talk. So there we go. So at QQ Trend, our main data product is a live data streaming, signal streaming service, mainly aimed at the finance industry. So as an example, we might be monitoring the dollar-yen exchange rate and predicting if it's going to go up or down in the next time period, or perhaps predicting the probability of a large move in the next time period, those kind of things. And the company was actually founded around this product, hence the name QQ Trend, back in 2011, 2012. But at the start of 2016, I wasn't happy with the predictability. It seemed a bit fragile sometimes. If any of you have done any Financial Times series prediction, you know it can work very nicely for 6 months, and then you lose all your money. So I was after something that would more robustly backtest. And I was casting around for some ideas. Oh, light. This is an actual video game. I have to... There we go. Find the right icon. And around the same time, you might remember AlphaGo suddenly had a huge breakthrough in the realm of computer Go. This was very exciting for me personally because I'd been working on computer Go since the mid-90s. Got a bit obsessive at certain times in my life. It's a very interesting, challenging problem. And I tend to be an optimist, or at least I was initially, believing computers can play this game very strongly. And so in late 1999, around 2000, on the Computer Go mailing list, John Tromp made a bet, or offered a bet, saying he'd bet $1,000 that no one could beat him within the next 10 years. No computer would beat him. And to put that in context, John is a very clever mathematician, but he's an average to strong Go player. Maybe equivalent to a black belt, as in a one-dan black belt. So the kind of level you could reach after a year or two of serious study of the game. And being a foolish optimist, I took him up on the bet. And then in December 2012, at an event in London, I lost and handed over $1,000, which was sad. It was also bad timing because Computer Go was just getting some breakthroughs at that time. And a year later, he did a rematch and lost 4-1. So I just got my timing 1 year out. Or he got his timing 1 year right, depending on your point of view. But still, when AlphaGo suddenly was beating top professionals, that was a shock for me and for everyone who was following Computer Go. It was 5 to 10 years too early. And so I wanted to learn what this deep learning thing was, how it was different. I'd actually looked at neural nets applied to Go back in the late 90s, and they were rubbish. Dismissed them immediately. They didn't look like they were going to scale, and there was no, they were easily beaten by the simplest of algorithms. So I was curious what was different. And of course, I was curious, could I learn to apply this to financial data series? Now, I was already doing a lot of pre-processing data engineering in R, so that was my first criteria. And my second was I didn't want to waste too much time on this. I wanted to get up to speed quickly. And both those are what led me to H2O. Oh, hang on. There we go. So, it ticked the first box. It has R support. It was also ticking a lot of other boxes. Python, Java, CoffeeScript. There's a web interface I might show briefly in a moment. Supported on all operating systems. Scales to clusters like EC2 very nicely. So I got in a bit deeper. There we go. And it ticked another box. It was easy to use, especially for deep learning. As you'll see in a moment, it's literally a one-liner to make a deep learning model. And yet it's still scalable to big data. And the third point I have there, it's a mature architecture. I think it was first released in 2011 and had gone through a couple of, what's the word I'm after? Architecture, re-architecturings. So it was on version 3 by 2015. That gives you some confidence that they've made the mistakes and worked out the way around them. So I got in even deeper. There we go. And it ticked another big box. It was open source. In particular, it was an Apache license. I'm not a fan of GPL, but Apache I can work with. So you can use it for commercial use with very little restriction. There's also an active community, a company behind it. Jo can perhaps tell me how big the company is. I think it's perhaps 60, 70 people. 70. Right. And so I'm in pretty deep at this point, and I decide this is the product I'm going to go with for the company. And as a programmer, what I normally do at this point is I go and find the O'Reilly book on the subject. And there wasn't one. So I'd previously written a book for O'Reilly. This is on data streaming, low latency data streaming to the web browser using HTML5. Have a look later if you're interested. So I asked some of the editors at O'Reilly if there was a book in progress and I could be a technical reviewer, sorry. And one thing led to another, and I ended up getting in almost over my head and offering to write the book. I gave myself a couple of months, and it took 5 or 6 months. But I learned a lot along the way. I learned a lot about H2O. I learned a lot about machine learning. Writing a book forces you to fill in those gaps in your knowledge that you've been glossing over before. Where am I up to? Yes. Yeah, so it's been selling well. It was released, the book was released at the start of this year, or December last year. And there's some of the data visualization we do in the company. There we go. We've been having some good endorsements. People I highly respect and believe all their opinions. I've got another one coming. There we go. Another fine, upstanding member of the community. Obviously loves the book. And how do I get back? Yeah. And it continues, one thing leading to another, and I'm now working on a video course on H2O to be published on Coursera, probably in the next month or two. It will be free unless you want the certificate and to take the graded tests, which is a nominal fee, about $50, I think. So that will be a certificate in H2O that you can show to an employer or just to give yourself confidence that you know what you're doing. OK, I'm going to switch to the live coding demo now and show you how easy it is. I've got the link here somewhere. There we go. Just out of interest, does anyone recognize that building? I'd be very surprised. It's actually the Norwich Union building. Because my live demo is going to be on life insurance. And yeah, I borrowed this from a Kaggle competition. The idea, I think it's prudential. When you apply for life insurance as a customer, well, the life insurer has to send you off for health checks to see their risk, how much you're likely to cost them over the lifetime of the policy. If they could find a way to not do that, it would save them a lot of money. So the idea is you take in you ask the user various questions about their medical history, their age, their height, their weight, and so on. And the ones who look very healthy on paper, have a very low risk, you just give them the policy straight away. The ones that look very high risk, you can dismiss straight away. And it's just the ones in the middle you'll be giving the health check, the grey area. So potentially it could save you a lot of money. So that's the Kaggle problem, and we're going to look at it. Of the people who have a preference, who would like to see this in R and who would like to see it in Python? Can I have an R raise of hands? Oh, quite a few. And who would like to see it in Python? That's what I was expecting. I'll jump back to the R every now and again. No. OK, this is the problem. In this data set, you provided over 100 variables describing attributes of life insurance applicants. The task is to predict the response variable. It's an ordinal measure of risk that has 8 levels. So in the database, it goes 1, 2, 3, 4, 5, 6, 7, 8. 8 means they gave them the policy. 1 means they didn't, with grey scales between. There's a lot of data fields. Can you see that? OK, good. As you'll see, these fields, age, height, weight, have been normalized. I don't have any information about how they've been normalized, if it was linear or using the standard deviation. And then this is the only information I've been given on these other variables. Nothing much more than I could have guessed from the variable name. So in that sense, this is quite unrealistic. If this was a real client, I wouldn't accept this. I'd be going into them and saying, what does this all mean? How do you use this? How do you make decisions yourself? But we'll go with it for a demo. I'd forgotten about that. They've helpfully told us which of these are categorical, and I'll come back to that in a minute. Right, there we are, Jupyter. So to install H2O, it's really easy, but I'm not going to show it because it will take about 3 or 4 minutes to download. In Python, you'll use pip install H2O, and that will get all the dependencies for you. In R, I can show you actually. In R, it's install packages H2O. So couldn't be easier. And again, that will get all the dependencies from CRAN for you. So the first command I do is import H2O, bring the library in, and then init, initialize H2O. If H2O has a client-server model, even if you're on a single machine, you're still running client-server with separate memory spaces. So you need to keep remembering that. Everything is in the memory space of H2O. Your client, whether it's R or Python, is really just a dumb client. If you don't have a cluster running, it will create one locally for you. Why isn't it working? Hang on, I've had a crash. That's not good timing. Oops, we're having problems connecting you.
Bear with us.
Yeah, I think it's me.
Just what you want during a live demo.
Yeah.
Drop down.
I think we're going to have to reboot.
So reboot
Got nothing.
from your laptop.
Yeah. Should be 5 minutes. Yeah.
Make a topic of conversation.
Yes, sorry.
Does anyone know any data science jokes? That was one. I may as well intervene. Can I get a ray of hands? Anyone who's actually heard of Shop Direct before? Okay, fair few. Anyone heard of Berry? A few more. Littlewoods. There you go. So we need to work on our branding team. They're sitting over there. They've all come from Liverpool today. So basically, one of the reasons we've moved to London is because our head office up in Liverpool is known very well across the northwest, but not in London. So part of my job is trying to get that exposure and trying to ramp it up here. And we've got this massive space. This can actually hold 250 people. It's a U-shaped office. You're only sitting in one section of it. This is the Shop Direct side. We've also got Berry on the other side. And raise of hands again, who has been to Liverpool? Okay. Raise of hands who would move to Liverpool. A fair few. So that's one of the reasons we've got an office, because we're finding it very notoriously difficult to recruit up in the northwest. And where's the talent? Show of hands, who's in London? There you go. So that's basically why we're here. So if anyone wants to know more about science development, we're going to have UX designers, we're going to have Scrum Masters. There's leaflets scattered around the place, or you can grab me. Just a quick show of hands. Who actually knows my name? Who actually knows me? Who am I speaking to? Not as many. Not as many. So if you want to speak to me afterwards, you can. Hopefully we're rebooting soon.
I'm just about there, and then we've got to do
I
this
can fill a
bit.
space of time, no problem. Otherwise we get spectators. Joe, this is your website. This is fine. This will go full screen. Good minimize that. Okay. Round of applause for Darren for sorting that out. Cheers.
Thanks for covering. Okay, and the cluster is already back up. I was about to say, in the H2O init parameters is where you would specify if you're connecting to a remote cluster, say on an Amazon network. H2O is very good at scaling across machines. It's really good if you have very large data. That's where the scaling will work well, because it will be splitting the data across each machine. So if you have 8 machines, each with 16 gigs and a 100 gigabyte database, it will split that up, 12.5 gigs on each machine. If you have very small data and you're using 8 machines to try and speed it up, it won't be so effective. You won't get linear scaling. Okay. I'm going to bring the data in using the obvious command, H2O import file. And this is the file exactly as I downloaded from Kaggle. And this is now sitting in the memory of the H2O server. I'm going to keep calling it the H2O server or the H2O cluster, even though it's sitting on the same machine. Next command is just going to show how to do a bit of data engineering or data exploration. And again, if the data was that 100 gigabytes, this command would still work across those 8 machines. So I can find out correlations, in this case, between height and weight, between over very large databases that wouldn't fit in the memory of a single machine, so wouldn't be accessible using R or Python normally. We're getting a 0.61 correlation between height and weight. That's a quick sanity check. It sounds about right. It shouldn't be 0. It shouldn't be 1. 0.6 sounds about right. So at the bottom of the other screen, I had a list of categoricals. H2O is generally very good at working out which fields are numeric, which fields are categories, which are strings, dates, and so on. It got confused here, and I need to tell it which are the categories because they've been marked in the file using numbers. So it played safe and imported them as numbers. So this will just tell it they're actually categories. I'm forgetting. There we go. Now I'm going to split into 90%. The 0.9 means 90% as training data, 10% as test data. The random seed is just for the demo purposes. Normally you wouldn't use it. And check how many rows I've got. 53,000 training, 6,000 test rows, and we have 128 columns. So let's have a look. What this command is doing, going back to our cluster idea, is it's downloading one row of data from the cluster to my client and displaying it. So let's look at our first person in the database. You can see there's a lot of numbers. There's not much to grab hold of here. If you were a human, given these numbers, asked to decide should I give him a life policy or not, you'd go, no idea. Nothing here is helpful. Medical keywords, medical history, the very final column, response 8. So whatever these columns are, it was obviously good because they gave him their life insurance policy. His age is slightly above average. 0.5 would be average if this is normalized. Slightly taller than average, much lighter than average, with a lower BMI than average. That may be the case, or this may be a suggestion that the data has been scaled linearly, and you maybe have a few very heavy people in the database. Normally I wouldn't look at the test data, but we're going to test against this in a moment. So different numbers, not much to grab hold on. Average age, quite tall, again quite light. Similar BMI. And whoever this first person is in our database, he also got a life insurance policy. So I'm going to, in my variable x, list the columns I want to use to learn from. You could specify them by name, but because it's 128 columns is a lot, I'm just using their column index. So I'm going to learn from columns 1 to 127. This is Python, so we're counting from 0. So the very first column you might have noticed was ID, and I got rid of it. But everything else, I don't know what it is, so I've decided to learn from it. And the very last column is what we're trying to learn. So in Y, I'm putting what I want to learn. In X, I'm putting the fields I want to learn from. I said earlier it was a one-liner. In Python, it's done as a two-liner for people familiar with scikit. So you create an object, and then you train it. I'll just start running. I'll just run the line before. Right. There we go. I'm running with all defaults here. The H2O defaults are really good. I don't tend to tune them much at all. I did change one thing, which is epochs to 1. Epochs is how much effort is going to put in to learn, really. And the default is 10. So I just set it to 1 to keep us moving along. So we've built our model on those 53,000 rows. Let's have a look at it. Reporting on the train data, so self-evaluation, MSE of 3.6, root mean squared at that. I'm going to focus on mean arithmetic error. Interesting point here, the response was an ordinal, meaning it's a number, but an ordered number. So 1, 2, 3, 4, 5, 6, 7, 8. It's not a floating point. There are no 7.5s, 3.5s in the database. I've chosen to learn it as a floating point number because ordinal means 8 is better than 7, is better than 6, is better than 5. In fact, I'll come back to MAE. I'm going to skip over all of this and do a prediction. So I'm going to use the model. Is everyone seeing this? Is the font big enough, by the way? Yeah. So 0, I'm going to take the first row, and I'm just going to take the columns we learn from. I don't really need to do this, but I want to show that I'm not giving it the prediction column. I'm not giving it the answer when I do my prediction. OK. And it predicted a 7.079. So a 7. And as you saw earlier, the correct answer was 8. So the model did fairly well there. Right, we've got 6,060 of those, and I'm not going to do predict for every one. I'll just show how to do a batch. So grabbing the first 6 people and the first 6 answers, and the cbind. The cbind command will be happening on the server as well, and then I'm downloading the joined table. I think. So the first one, it predicted 7, it was an 8. Next one, it got badly wrong. Predicted a 6, and they weren't being given life insurance. No way. Next one right, next one wrong. The grey area is it's not too far away. Our mean arithmetic error on the training data was 1.45. So on average, it's 1.45 categories wrong, 1.5. So this one at the bottom is quite typical because it's 1.1 away, 2 away. But yeah, we don't want to go through all 6,000, so I'm going to run a performance which will evaluate how the model did across the whole 6,000 rows. 1.47. And I think that's quite reasonable. Compared to, if I was the human, I'd be saying 3.5 for every one, 4 for every one, because I've got no idea how to judge that. So my personal error would be a mean arithmetic error of 3 to 4, 3.5. So I think it's done quite well. I'll just compare the performance on the training data. Slightly lower, slightly better numbers, but in the same ballpark, so I don't think the model has overfitted. It shouldn't after just one epoch. I want to show, with the next couple of lines, how easy it is to switch to a different algorithm. It's the same API for each of the algorithms H2O supports. So here I'm going to use, it says gradient boosting, a GBM, which is a type of decision tree. And if you, are there any Kaglers here, other than my next speaker? Oh, not that many, but you'll know GBMs tend to be more popular than deep learning on the Kaggle site for many problems. Let's have a look, see how we do. Where am I? There we are. Trains fairly quickly. I'm using all defaults, which I think is about 50 trees. And it's done slightly better, 1.43. So I'm happy with that. I did go on and do a bit of tuning to find a better model. I lowered the sample rate, increased the trees. H2O has a very nice feature called early stopping, which you can use on all the algorithms. So normally you'd be looking at your training curve and your validation error, and when the validation flattens out, you'd stop learning, which is a very tedious manual process. So early stopping just automates that for you, makes your life easier. Gives you a better model, is the bottom line. I will just build it. I think it will take a while. And that was my best model. Even tuning the deep learning, I couldn't outperform that on this data set. So I did no data engineering at all. I wrote a couple of lines of code, plus importing the data and so on. It's very easy, 10 minutes, and I got a reasonable model out at the end. This is one of the strengths of H2O, very easy to use, but still good results. And that could have scaled, we had, what, 55,000 rows? We could have scaled to 5 million rows using exactly the same one-liner. Okay, change of pace. I'm now going to switch to my advanced topic. And I had wanted to talk about RNNs, recurrent neural networks, applied to NLP, so for automatic generation of text, which is a project I'm working on for a very interesting and challenging project, working on for a client at the moment. But there were too many bleeding edge parts, and I couldn't get it to work in time. So I changed plan. And I'm going to talk about a topic from the book, actually, which I call poor man's convolution. How many people here know of convolutional networks? Good. So I won't need to go into that too much today then. Throughout the book, I concentrated on how to use H2O and how to tune the models, a lot of the mechanical stuff. But throughout the book, I was saying, yeah, tuning gives you a few percent, using an ensemble gives you another couple of percent, but the real gains are data engineering, or going to get more data is also very effective, improving the quality of your data, these kind of things. So at the end of the book, the last half a chapter, I showed how to do some of these things applied to the MNIST data set, which is handwriting digit recognition. H2O doesn't come with convolutional neural networks, and as you know, CNN's convolutional neural networks are a very good fit for visual data. So I wondered what I could do, how I could work around this. It wasn't the only thing I tried. There's quite a few ideas in here at the back. I increased the size of the data using rotations. I used autoencoders to generate new features and so on. Have a look when you buy the book. Right, I just need to find my slides now because we've rebooted. Give me a moment. No. Okay, this is just an example of what a convolutional network is doing. It takes an image and then it turns it into small overlapping tiles and analyzes each of those tiles separately. So this is for facial recognition, a much more complicated task. You see the first convolutional network is finding edges. The next layer of the convolution is turning those edges into facial features. You can just about make out noses, eyes, and mouths. And then one more layer is creating faces. This isn't a database, these are facial archetypes. So if we put, say, Bob through the system, Bob might turn out to be 0.3 of this one, 0.1 of this face, none of this face, 0.8 of this face, and so on. And what would come out of this, you would then feed into a fully connected neural network, just like H2O offers me. So I wondered, could I generate some of these patterns myself and then use H2O as the last couple of layers? Oops, hang on. OK, that's just the same idea again. But that was what I managed to do, is I made some 5x5 patterns, which I'll explain in a moment. And then I used a 2x2 max pooling, which gave me 12x12. Yeah, that makes sense. Gave me 144 outputs. I made 12 patterns. Does that add up? Whatever the sums are, I ended up with 1,728 columns coming out of my handmade convolution. I put in the other data engineering I had, which gave me 2,200 columns altogether. Using data rotation and so on, I turned the 50,000 MNIST database into 1.2 million. So I ended up with a database, when compressed in H2O's memory, of 17 gigabytes, which is a feature I wanted to mention. H2O, it's an in-memory database, but the data is always stored compressed. And that doesn't seem to affect performance. It's still quick, but it means you can store more data in memory. You can get more out of your hardware. So I was doing this about a year ago. I set up 4 large EC2 machines. And so I had a cluster of 144 cores, about 100 gigabytes or so of memory. Going back to how I trained, do I have a slide? Oh, that'll do. When I was looking through some papers on MNIST and how other people had got good scores, low error rates, I noticed the patterns were very similar to what I'd seen when I was doing principal component analysis, PCA, and what I saw when I was doing autoencoder analysis. So I thought, H2O has those, maybe I can use those. So what I did is I wrote a simple R script that would go across the image and extract every 5x5 tile out. What I did before that was I went through my training data and found the 1,000 most difficult training samples. And I just used those rather than the whole 50,000. And the thinking behind that is if you want to get a good MNIST score, you don't care about people with nice, neat handwriting. You care about the people with the scruffy handwriting. You care about the Bart Simpsons of the world, the people who can barely draw. So those were the data I wanted to be focusing on. So I took the 1,000 most difficult, extracted all the 5x5 tiles out of those 1,000 images, fed them through an autoencoder, which is the left 6 columns here, and fed them through principal components, which is the right 6. Now, this was a very quick process compared to training a convolutional network. I saved myself a lot of time. This is why I call it a poor man's convolutional network. You can just see how the patterns are applying to some MNIST digits here. And there's quite a distinct difference. Autoencoder is treating all dimensions the same. They all have equal weight. So you can see they're all noisy, similarly noisy. Whereas principal component, the first pattern, is taking the most information out of this data. And the second pattern is taking the most information out of what's left. And then the third pattern, the most information out of what's left after that, and so on. So, yeah. And when I looked at that, I thought those are quite reasonable. I went with 12. Just looking at it now, I realize I could probably have used a lot more patterns and still got better results. But that was a nice compromise, and my book deadline was approaching rapidly. So it was a bit like a real-world project at this point. And I'm just going to quickly wrap up there. Using a single model, as deep learning was best on MNIST, but using just a single model, my best MNIST score was 138 or 148? 138, so about 1.4% error. Using a lot more data and the various ideas I described at the end of the book, some data engineering, including this idea, I got that down to, I think it was 56. So around 0.5% error. And when you consider its diminishing returns, that's quite a significant improvement from doing some data engineering. The data set, if you've looked at MNIST data, there's some noise. There's about 20, 30 samples that no one's going to get. So I'm not far off human performance there. I was quite pleased. OK, that wasn't too advanced, was it? You're still alive? Good. So just to summarize the whole talk, I found H2O to be very easy to use, very scalable, and give good results. It also saves you having to work all the little details out yourself. You don't have to code momentum or gradient descent or dropouts, or any of that stuff yourself. And if you've ever tried, it's very easy to make a mistake. So it's higher level than many of the alternatives, but that's an advantage in my book. And that's basically all I had to say. Thank you. Any questions? 1 second. Yikes.
Thank you. Thanks for the demos. They're really, really good to see and really nice and practical. The thing that really annoys me about scikit-learn is the fact that you have to dummy variable everything because it can't deal with non-kind of dimensional variables. Where I know you did it in your example. Can H2O deal with complete factors in the same way R can, even when you're doing it in Python?
Can you explain? Sorry.
So if you have like a kind of 3-factor thing you're trying to predict, you know, like low, medium, high, or something that's not essentially like on a scale, like you did it, but something that's completely individual things. It can do categorical and classification tasks on factors without having to dummy it, right?
Yes.
Awesome.
I'm not familiar with scikit, so I've never had to dummy.
It's really annoying. It's really annoying.
Yes, it just works out of the box.
Sweet.
H2O will also normalize all your input variables. It will do the one-hot encoding for you. You just throw your data in.
Sweet. Cool.
So, thanks for the great talk. I have actually a question about the thing which you didn't talk about, the RNNs thing. And I wanted to know, I know the space. I know RNNs, I know LSTMs. Did you actually use LSTMs or RNNs with H2O? Or did you use some R-based time series and then did something with that?
Okay. H2O has a development version called Deep Water, which is basically a wrapper around TensorFlow, MXNet, and another one I've forgotten. So I could use RNNs and I could use convolutional networks through that route. It's quite hard to set up, and I'm hoping Joe is going to do a talk showing how to install Deep Water sometime.
I did so many before that, yeah.
But I'm personally using MXNet, and I'm using LSTMs.
Right. But through H2O?
Not using H2O yet.
Right.
Because I might as well build the model and then bring it into Deep Water later.
Cool. Understood. Thank you.
Next question?
Thank you for this great talk. Oh, sorry.
That's all right. We've got time for both.
Thank you, Darren. I wonder, can you introduce some tricks to tune the neural network? How do you select the hyperparameter, like the number of layers and the number of neurons in each layer? Like this kind of tricks. Thank you.
The short answer is I use a grid. I make a few guesses, put it on overnight, and see what comes out on top. H2O grid is nice and easy to use, works equally well in Python or R, and you can go and investigate the models afterwards. The medium length answer is by the book, because that's what most of the book is about, is how to tune those parameters. I find particularly deep learning tuning to be more art than science. I can't predict what's going to work well in advance, so I do literally just try a few random things and see which one comes out.
Okay. Let's say I'm a beginner and I want to choose between Keras and H2O. And I have two projects. One is the life assurance, the one you showed us, and I have a miniset data set. I want to know what is the better, which one has better performance. Should I use H2O or should I use Keras, for example? I don't know which one to choose because I'm a beginner.
From performance point of view, I doubt there's going to be much difference between any of them. H2O, TensorFlow, MXNet. Keras I'm not so familiar with, but I think it's a layer on top of TensorFlow. Is that right?
Yes.
Because ultimately it's just got to go and build that model, and they're all using very similar algorithms under the surface. So I might be biased, but I would choose the one that you find easiest to use, the one that allows you to express your ideas most clearly. It's the same as programming language arguments.
Okay, thank you.
Got one here.
Thank you very much for the talk. Okay. I just wanted you to expand on autoencoders and another term you use, rotations, because I haven't come across that before.
Was I talking about rotating the MNIST data?
Yes.
That was a simple image, rotating it 2 degrees anti-clockwise, 2 degrees clockwise, just to generate more data,
Okay.
because people's handwriting is at different slants.
Okay.
Autoencoders, really interesting idea. One of my favorite topics is it's used as an unsupervised learning technique. So unsupervised means you don't have a label, you don't know the answer. So the idea is you take the question and pretend your question is your answer. So you take your input data and you put that as the output, the correct answer, and you tell the network, can you learn how to give this representation? And say you have 20 inputs, I should come around here, 20 inputs through to 20 outputs. If you had 20 hidden neurons, it's a really easy task. You just set all the weights to 1, and that's not right. But anyway, you set the weights to something and it will feed through and give you the correct answer. More interesting is when you use fewer hidden neurons in the middle than you have inputs. So in the MNIST example, I have 5 by 5. I have 25 inputs, and I went through 6 hidden neurons and fed through to 25 outputs. And I asked the network to learn how to compress those 25 inputs into 6. And each of those hidden neurons gave me 1 pattern. So you can think of it as automatic feature generation from your data. And they tend to be very good features because they're in a language that the machine can understand. Or you can think about it as compression, dimension reduction. But it's a very useful technique, and it's well worth using as a pre-processing step.
Okay. Let's go back to the life insurance example. I wondered how different your algorithm would have responded if you had 3 labels, the 1, the 8, and the grey area, instead of 8 labels.
And I would have done that as a classification. I think that would have given me better results.
Okay.
And that's interesting, isn't it? Because, yes, I could then have fed them back out as 2, 4, and 7, 2, 5, and 7, something like that.
Because just the grey area that the insurer would want to perform
Yes.
their risk assessment on.
Yes, that's probably a good approach. If that was a real problem, though, I would want to know what the input fields are. That would be my first port of call. Okay, thank you.
So we have a short break for 5 minutes, so please come back at 7:30, and there will be the next talk by Marios. Thank you.